Hello students, today in this video we will see the rectification of curves when the curves are given by parametric equations. Now if the equation of the curve given to us is in the form x is equal to f of t and y is equal to g of t. This is the equation of the curve. It is the parametric equation, or we can say this is a parametric curve. Then s, that is the length of the arc of the curve, it will be equal to integral t1 to t2 under root of dx by dt square plus dy by dt square into dt. So this is the formula to find the length of the arc of the curve. Now we'll see an example. Now the example given to us, it is find the length of the arc of the cycloid x is equal to a theta minus sine theta, y is equal to a 1 minus cos theta between two consecutive cusps. So we have been given a cycloid and we have to find the length of the arc of the cycloid between two consecutive cusps. Now we have the cycloid as shown here. This is theta is equal to 0. This is the cusp. This is the origin. Then we have theta is equal to 2 pi. Here we have another cusp. That is, we have to find the length of the arc of the cycloid between these two cusps. That is, theta is equal to 0 and theta is equal to 2 pi. So now we will proceed. We have x is equal to a theta minus sine theta. We'll differentiate x with respect to theta. So we have dx by d theta is equal to a. Derivative of theta is 1 and that of sine theta is cos theta. So we have dx by d theta is equal to a 1 minus cos theta. We have y is equal to a 1 minus cos theta. And we'll differentiate y with respect to theta. So we have dy by d theta is equal to a, derivative of 1 is 0 and that of cos theta is minus sine theta and we have is minus sign. So we have it as sine theta. So dy by d theta is a sine theta. Now dx by d theta whole square plus dy by d theta whole square. It will be equal to square of this, that will be a square 1 minus cos theta whole square plus square of this term. It is a square sine square theta. So it will be a square. We'll expand this bracket. It is 1 minus 2 cos theta plus cos square theta plus we'll have this sine square theta here with a square common as outside. So what we have is a square. This cos square theta plus sine square theta is 1. 1 plus 1 we have it as 2 minus 2 cos theta. We'll take this 2 outside. It is equal to 2a square 1 minus cos theta. It is equal to 2a square. For 1 minus cos theta we can write as 2 sine square theta by 2. So what we have is 4a square sine square theta by 2. Now we know for a parametric curve the length of the arc of the curve, that is s, it is equal to theta 1 to theta 2 integral. It's under root dx by d theta square plus dy by d theta square into d theta. So what we have is integral, we have seen. We have theta is equal to 0 to theta is equal to 2 pi. Because this is one cusp and this is the another cusp. And we have to find the length of the arc of the curve between these two cusps. So theta will be from 0 to 2 pi. So we have integral theta is equal to 0 to 2 pi under root of, we have found out this term as 4a square sine square theta by 2 into d theta. So it will be equal to, this 4a square is constant, under root of that will be 2a, it will be outside the integral sign, integral 0 to 2 pi under root of sine square theta by 2 is sine of theta by 2. So we have it as 2a and integral sine of theta by 2 is minus cos of theta by 2 upon 1 by 2. And the limits are from 0 to 2 pi. In the next step, we'll have this minus and this 1 upon 2 outside and simplify it. So what we have is minus 2a into 2 into cos of, now we have theta by 2. First we'll substitute theta as 2 pi. So we have cos of 2 pi by 2 minus, we'll substitute theta as 0. So we have minus cos of 0. So what we have is minus 4a. This is cos of 2 pi by 2, that is cos of pi. It is minus 1 minus cos of 0 is 1. So what we have is minus 4a into minus 2. So it is 8a. That is the length of the arc between the two cusps of the cycloid. It is equal to 8a. Now we'll see at another example. We have been asked to find the complete arc length of the curve x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3. We know the given curve is an asteroid and the parametric equations for the curve are x is equal to a cos cube theta and y is equal to a sin cube theta. And you have to find the complete arc length of the curve. Now we'll differentiate these two equations with respect to theta. So what we have is dx by d theta, it will be equal to, we'll differentiate this with respect to theta. We have it as minus 3a cos square theta sin theta. Because it's a is constant, derivative of cos cube theta will be 3 cos square theta and derivative of cos theta is minus sin theta. So we have it as minus 3a cos square theta sin theta. dy by d theta is equal to, differentiate this with respect to theta, it is 3a sin square theta cos theta. Now dx by d theta square plus dy by d theta square. So it will be square of this term plus square of this term. So what you have is square of this, it is 9a square cos raised to 4 theta sin square theta plus square of this term, it is 9a square sin raised to 4 theta cos square theta. Now from this we can have 9a square sin square theta and cos square theta as common. We'll take it outside. So what remains in the bracket is sin square theta plus cos square theta, and that is equal to 1. So what we have is 9a square sin square theta cos square theta. So now next we have to find the length of the arc of the curve. Now what we'll do, we'll first, this is the asteroid. Now this is theta is equal to 0, this is theta is equal to pi by 2, then you will have here theta is pi and theta is 3 pi by 2. First we'll find the length of the arc of the curve from theta is equal to 0 to theta is equal to pi by 2. So S, that is the length of the arc of the curve, it's integral theta 1 to theta 2 under root of dx by d theta square plus dy by d theta square into d theta. So it is integral 0 to pi by 2. We know this term, we have found out, it is equal to 9a square sin square theta cos square theta d theta. So it is equal to integral 0 to pi by 2 3a sin theta cos theta d theta. So it can be written as 3a will multiply and divided by 2. So we have 3a by 2 integral 0 to pi by 2 sin theta cos theta d theta, which can be written as 3a by 2 integral 0 to pi by 2. This term can be written as sin of 2 theta d theta. So what we have is 3a by 2 and integral of sin 2 theta is minus cos 2 theta upon 2 and the limits are from 0 to pi by 2. So what we have is, we'll take this minus 1 by 2 outside. We have minus 3 upon 4. It is into cos of 2 times, substitute theta as pi by 2, minus cos of 2 times, substitute theta as 0. So it will be minus 3a by 4 into 2 will get cancelled. We have cos of pi, that is minus 1, minus cos of 0 is 1. So what we have is minus 3a by 4 into minus 2. So it is 3a by 2. But this is the length of the arc of the curve only in the first quadrant. We have taken the limits from 0 to pi by 2. We have found out the length of the arc of the curve in the first quadrant. But we have to find the total length of the curve. So total length of the curve S will be 4 times this value. So it will be 4 into 3a by 2. So it will be equal to 6a. Thank you.